cherished viewers out there. I welcome you back once again to my YouTube channel, Rediscover Your Touch. Actually, we'll be continuing from whence we stopped concerning circle theorem. So we'll be actually taking theorem 3 and we'll deliberate over how well we can apprehend theorem 3. But before we start, I would urge you guys out there to take 1 minute of your time to subscribe to my YouTube channel, to like my video, and also to do what to share this lesson among your colleagues out there who might be in need of this knowledge. Alright, so without wasting much time, we'll set sail and then we'll deliberate over the theorem to see how well we can understand this. Okay, so theorem 3 of plane geometry 2 states that equal chords or arcs subtend equal angles at the center and circumference of a circle. So equal chords or arcs subtend equal angles at the center and circumference of a circle. So you realize that just like theorem 2, we are still dealing with what the equality of angles on certain conditions, right? So we are actually going to have our senses that we are really going to tackle illustrative example 1, and then we'll also talk about the illustration II in order to fit to this merging aspect of circle theorem. So we are going to look at the instances whereby the angles are being connected at the center. So we'll be having the angles connected at the center in example 2 or illustration II. And then we'll also talk about whence we are going to have our angles being equal at the circumference in illustration I. So per that, we are going to have our angles formed here. So in illustrative example I, we are actually going to have R equal chords to be line QR, or chord QR is equal to chord BC. I trust to see that as illustrated on the board. So chord BC is equal to chord QR, and per the theorem 3, equal chords or arcs subtend equal angles at the circumference of a circle. So we are taking the aspect of circumference of a circle. So in that sense, supposing I choose to represent it with a variable, let's say Q. Let's say Q. So Q degrees in this angle is likely going to be equal to this angle as well. That is angle QPR is equal to angle BAC. So we are still going to have Q degrees here as well as Q degrees here as well. So that alone speculates that equal chords or arcs subtend equal angles at the circumference of a circle. For now, I'm showing it at the center because our illustration I does not tackle equal angles at the center. It rather is translated in example or illustration II, and we'll be tackling that as well. So far, I trust you understand the instances whereby we'll be having our angles being equal at the circumference when we have equal chords. So the equal chords are chord QR being equal to chord BC, and showing technically the equality is when you have a mark on each of the chord, demonstrating that those chords are equal. And I trust you really apprehend such signal. Now moving on to illustration II, like as stated in the theorem, that is equal chords or arcs really subtend equal angles at the center. So over here we are focusing at the angles posited at the center of the circle within the theorem. So we are really going to have our chord SR being equal to chord PQ. Chord SR is being equal to chord PQ. And we show that technicality by taking chord SR and similarly chord PQ as depicted on the board. And for that matter, whichever angle that is being formed at each of the center ought to be equal. So we are really going to have instances. Supposing I choose to represent it by a variable. So let's say b degrees at angle SOR, at angle SOR. We are really going to have angle POQ to be the same angle, because equal angles or equal chords or arcs subtend equal angles at the center. So we are going to have angle POQ to be also B degrees. POQ to be also B degrees. So you realize that we've merged two aspects of the theorems into theorem 3. That is angles being subtended on the same equal chords at the circumference or either at the center are equal. So that is per se equal chords or arcs subtend equal angles at the center and circumference of a circle. And I trust so far you've really apprehend my deliberations on circle theorem 3. It is also as simple as compared to circle theorem 2. And I trust you really grasp what we've discussed so far. And in my next video, we'll actually be tackling examples on this theorem 3. And we'll be seeing how well we can really manipulate this theorem in order to find our desired result for the respective questions. Okay, so here comes the times again where we draw curtains on our precise lesson on circle theorem 3. So I would urge you guys out there once more to subscribe to my YouTube channel, to also like my video, and do well to share this video among your colleagues who might really be in need of this knowledge. Once again, I'm your host, Tutor Ebenezer Pobi, and I'll say goodbye to you all. Bye.